Hey everyone, this is Refix, and I've been developing a 2D game in Python that's as biologically accurate as possible. So my game is about a pathogen, or a virus, that fights the immune system to infect the bloodstream and take over humanity. So far, I have macrophage, which eats pathogens, or the player, white blood cells, that chase the player until they reach the bloodstream, I have cytotoxic T cells that don't do anything yet, and the player, a pathogen or a virus that can eat red blood cells. Since right now all the player can do is infect, run away, and sprint, I wanted to give the player some sort of defense. So I invented Glacia. Glacia is some sort of green mucus that slows down the immune system. I made a simple animation in asesprite of it getting released by the pathogen. Here it is in-game. It slows down the macrophage and white blood cells that try and eat the pathogen. So the way it works, as soon as the animation is done, it drops the glacia on the ground, and if enemies collide with it, their speed gets set to 1.5 and permits the player to run away. I have more ideas of more defense attacks, but that one will do for now. So now we're going into a little bit of biology. My new addition to the immune system's defense are the helper T cells. Now, technically, they're supposed to alert and help the white blood cells, and we're gonna totally ignore that and make them activate macrophage, the weird tentacular blob that eats virus. Why? Because I can. Sue me. Actually, maybe not. I'm too poor for lawyers. Anyways, I made them pink and semi-realistic with an exclamation point that appears when near the player. So this is how they behave. I randomly generate a position for them to spawn in. They aren't active until the player collides within a 50 pixel radius around the helper T cell, in which they spawn in defenses to neutralize the player. So the macrophage are hidden until activated by helper T cells. And I also added a swirly animation to the cytotoxic T cells to make them more visually appealing. One of the problems that I struggle with the most in game dev is background design. I cannot draw proper pixel art of that scale because I started only a few months ago. So to work on these skills, I played around for about an hour and a half and didn't really like the background. In my game, I have a parallax effect, which means my character moves with the background. The background isn't anchored down, which gives a more satisfying movement and it just feels visually way, way better. So the whole background is never shown. So that being said, hopefully nobody will realize how bad it actually looks. I will repaint the background later on, but this will do for now. So enjoy a quick montage. Okay, so I wanted to make my game a full screen game, but there were many issues with this. Everybody's monitors are different. Pygame has a way to get screen resolutions, but everything broke when I had bigger screens and two small screens. Look at the bottom, it glitches out and breaks. And also, the player cannot go out from the area, so a bigger monitor would just break how the player is supposed to move in the play area. And I tried fixing it, but nothing was working. So I instead put up the width and called it a day. We're gonna move on to some more technical stuff. So if I want to put multiple blood cells, I used to make something in Pygame that is called a surface and a rectangle. You can store that in a list, and if you made a for loop that contains the information of the location and what surface or image you want, you can then put each element of the list on screen. In this example, cell is the position and we're assigning it to the center of the rectangle. and then putting it on the screen using screen.blit. The problem with that, it's very hard to make them do anything, since you can't use a class to make their image or stats change. The options are very limited. Well, thankfully, Pygame has a built-in type of class that's called a sprite. I might make a tutorial on them since they are more advanced and complex, and not much documentation is out there online. Anyways, those sprites can add surfaces and rectangles together and can be used without for loops, which slow down performance. You can make funky stuff like duplicating antibodies to the mouse position and making them move off screen. So I wanted to do 4 things this week. Learn sprites in Pygame. My code was getting really messy, so get proper structure. Rewrite all my types of defenses into sprites instead of rectangles and surfaces. And finally, fix the background conception. We're going to start by cleaning up some code, optimizing my images into sprites, and rewriting about 200 lines of code into 80 lines. But if you watched it this far and is interested in Pygame or my game, consider subscribing and liking. It helps push the video to more people and helps me a ton. I haven't got a name for my game, so if you have any suggestions at all, leave them in the comments. I look at all of the comments. Now, for our last features, the sprite code makes it so when red blood cells are infected, they can move off screen and get deleted. And to prove why sprites are infinitely better, with the change of one value, I can display 400 helper T cells without any crash of the program. Look at this. Yes, it may be extremely slow, but it runs, and that's what matters. So, to end the video, this is what we accomplished. I will see you all next week. Goodbye.